Hello everyone, welcome to my channel. In this video, we will summarize how to access or subset elements from an object. The vectors that are used to subset objects are often called index vectors. There are 5 types of index vectors for subsetting objects. We've already learned some of them in the previous videos. The first type of index vector is the logical vector. The target vector is the vector that we will select components from. Most of the time, when we use a logical vector to select components from a vector, the length of the logical vector is the same as the target vector. The elements in the resulting vector are the ones that correspond to true from the logical index vector. If we include a missing value in the logical index vector, it will return a missing value as well. This example selects the element of vector A that is greater than 3. Since the logical index vector contains a missing value, this missing value generates a missing value in the result. This example shows how to select the non-missing elements from vector A. The is.na function returns a logical vector, indicating which elements from its argument are missing. Negating the result from the is.na function returns a logical vector that indicates the non-missing value. Then we can play this index vector within the square brackets to select non-missing elements from vector A. The second type of index vector is a vector that contains positive integers. The positive integers indicate the positions for selection. The resulting vector contains the values from the target, corresponding to the specified position. This example selects first, second, third, and second elements from vector A. Recall that the which function returns the true indices of a logical vector. When we use the which function to convert a logical vector to an integer vector, the missing values are treated as false. If the target vector contains any missing values, we can use the which function to create an integer vector for subsetting. In the first example, we use the logical index vector to select elements in A that are greater than 3. Since vector A contains a missing value, using the logical index vector generates one missing value in the result. After we use the which function to convert the logical index vector to a positive index vector, only the elements that are greater than 3 are selected. The third type of indexing is using negative integers. Using a negative integer index vector specifies the target vector's position to be excluded in the result. We cannot mix positive and negative indexes together. This example selects the element from vector A by excluding the first and the fourth element. The fourth type is using character strings to select elements. Character indexing only applies to vectors with the names attribute. In this example, we first assign names to vector A with letters A to E. Then we select elements in A with names equaling to A or C. The last type of indexing is leaving square brackets empty. In this case, all the components from the target vector are selected. We often use an empty index to select components from a matrix or a data frame. We can use any type of index vector on the left-hand side of the assignment. This example uses a logical index vector to replace the missing value with 0. Notice that the logical index vector applying for vector x is placed on the left-hand side of the assignment operator, and 0 is placed on the right-hand side of the assignment operator. The first example on this slide uses a positive integer index to replace the second and the fourth components of vector x with values 10 and 20. The second example uses a negative integer index to replace all the elements in x, except for the first and the second element, with a value 4. Character indexing can only be used for a vector with names. We first assign names to x with letters A to D. Then we replace the components in x with names equaling A or C with value 0. The second example illustrates the use of an empty index. If we use an empty index on the left-hand side of an assignment, it preserves the original object class and structure. This example shows how to replace each component of x with 0. Next, let's see how to subset matrices and arrays. The array X is created with 3 dimensions. In this example, the dim names are also assigned to the array. When we select elements from an array, we need to specify indices for each dimension and separate them by commas. The first example selects one element that is located at the first row, second column, and third page. The second example selects elements at the second row, first column, and second and third pages. When we select elements from an array, any of the 5 forms of indexing is allowed at each index position. If we use an empty index at a position, the full range for this position will be selected. For example, X is a 2 by 3 by 4 array. In this example, the first position is left empty, which means all the rows are selected. The second position uses a character index vector to select the first and third columns. The last position uses a negative index vector to select pages excluding the second and fourth pages. We can select components from a data frame by providing 2 indices. The first index is to select rows, and the second index is to select columns. Providing 2 indices to select components from a data frame is like selecting components from a matrix, since both data frames and matrices are 2-dimensional. D is a data frame with 3 variables. The first example selects the second and the third rows by including the index vector at the first position and leaving the second position within the square bracket empty. The second example selects the first and third columns. Both examples uses positive integer indexing. The first example on this slide uses a logical index vector to select rows with variable L equals A. The second example uses a character index vector to select variables M and N1. The last example selects variable L equals A and keeps variables M and N1 only. Instead of placing 2 index vectors at 2 positions, we can also use 1 index to select components from a data frame. Recall that a data frame is a special case of a list. If we only enclose 1 index vector within the square bracket, it behaves like subsetting a list. In this situation, we cannot select rows from a data frame. We can only select columns or variables. So far, we have learned 3 types of operators to select components, including $, single bracket, and double brackets. Let's summarize which operators to use when selecting components from an object. First, using single brackets always returns an object with the same data type as the target object. For example, when we select one single column from D, by using single brackets, the result is still a data frame. On the other hand, if we select one single column, by using either double brackets or the $sign operator, it will return a vector. By using single brackets, we can extract any number of elements from a data frame or a list. While using double brackets or the $sign can only extract one element. Another difference among these operators is that single or double brackets can evaluate its argument, while the $sign operator does not. In the first example, we enclose 1 plus 2 within the double square bracket. Since 1 plus 2 equals 3, the first command selects the third column of D. In the second example, we enclose an arithmetic operation within the single square bracket to select the second and the third columns of D. The last difference is that the $sign operator uses partial matching to exact an element, while single or double brackets do not. In the first example, we specify n instead of n1 to select n1 column by using the $sign operator. But we cannot perform similar action by using single or double brackets. Please keep in mind that using partial matching is not a good programming practice. In the last section, we will summarize the differences between simplifying and preserving subsetting. Simplifying subsetting means the result has the simplest data structure. Preserving subsetting means the result has the same data structure as its target object. So far, we have learned how to use single brackets to subset a vector. We can also use double brackets to subset a vector. In this example, V is a named vector. Selecting the first element from V by using double brackets removes the names attribute in the result. On the other hand, using the single brackets preserves the names attribute in the result. For a factor, simplifying subsetting means setting the drop option to false within the single square brackets removes the additional level in the result. Without setting the drop option to false, preserving subsetting keeps all the original levels in the result. Simplifying and preserving subsettings for a matrix only apply to selecting either one column or one row of a matrix. When we select one column or one row from a matrix, simplifying subsetting simplifies the result to a vector. Preserving subsetting returns a matrix with one single column or one single row, by setting the drop option to false. For a list object, simplifying subsetting utilizes double brackets to return the list content. For example, if the internal content is a vector, it will return a vector. Preserving subsetting uses single brackets. The result is always a list. Simplifying and preserving subsettings for a data frame only apply to selecting one column from a data frame. The example on the left selects the second column from the data frame D. Both commands are simplifying subsetting. The first example specifies 2 at the second position, and leaves the first position empty. The second example uses double square brackets to select the second column. Both methods return to a character vector. The examples on the right use preserving subsetting. The first example specifies 2 at the second position, leaves the first position empty, and sets the drop option to false, within the single square brackets. The second example uses one single index vector only, within single brackets. Both examples return a data frame with one single column. Now, let's review what we've learned from this video. In this video, we learned how to subset objects by using 5 types of index vectors, including logical, positive integer, negative integer, character, and empty. These 5 types of index vectors can be used to subset vectors, matrices, arrays, lists, and data frames. We also compared the differences between using single brackets, double brackets, and the $sign operator to select objects. I hope you enjoyed this video. Please like and subscribe to my channel, and click the bell icon to get new video updates.